These are the frequently asked questions for Algebra 2 for section 3.3a2. We'll look at number 22. It says the measure of theta of an angle in standard position is given. Find the exact values of cosine theta and sine theta for each angle measure. So for number 22, what you want to do is think visually, and hopefully you'll at least start thinking in terms of radians. And what we're doing is we're saying, well, we're going to go not all the way over to 1 pi. We need to go 2/3 of the way over. And then you start thinking, okay, thirds. If I did go 180 divided by 3, well, that would give me 60 degrees. So I've actually gone 2 of those 60 degrees, that would be 120. So what that's really leaving me here is a 60-degree angle. So if that's a 60-degree angle, that's a 60-degree angle, this is a 60-degree angle as we go through these. So now, what to do? Well, this is our nice 60-degree angle here. And what we would want to know is, what is the cosine and sine for that angle measure that's formed with that axis? And what we're really going to be looking for here is the cosine of 60 degrees and the sine of 60 degrees. But then we'll have to talk about whether or not they should be positive or negative as we work through this. So we have our little 60-degree angle. We can sing the song 30, 60, and 90. It's very easy to see. The short side is 1, the hypotenuse 2. The other side is the square root of 3. And so I'm looking at this and thinking, okay, now I have that 60-degree angle, but because I'm going to go to the left this time, that's going to be a negative 1. And then this is going to be the square root of 3 because it's going up, and this will be a 2. And then we can just use some SOHCAHTOA magic on this, since cosine, so ka, is adjacent over hypotenuse. Well, adjacent means right next to, so that's going to be negative 1 over 2. And then sine is opposite over hypotenuse, which would be the square root of 3 over 2. And there we are. So the cosine turns out to be negative because we would have to go to the left in second quadrant. But our square root of 3 over 2 is going to be positive. So again, a really visual process that you can use to go through these, and go through them pretty quickly once you remember your 30, 60, 90, and 45, 45, 90 triangles. Then number 27 says, use each circle to find the length of the indicated arc. Round your answer to the nearest tenth. And remember, our fancy new formula, very beautiful, very short, r theta. However, you must have radians in order to use this formula. So as I look at these 6, you'll notice every single one of these is in radians, but most of the time we'll have to check and make sure that we have that. So s equals r, and the radius is 5 here. And then theta is 2 pi over 3. And it did say round our answer to the nearest tenth, so really wouldn't have to do any reducing or anything, but 5 times 2 would give us 10 pi, so 10 times pi, and then divide that answer by 3. And it's 10.471975551. To the nearest tenth, we'll go with 10.5 for that length. And this would be in meters because that is the label that we see inside that circle. So all of these already have it in radians. It's really going to be about, doing a little bit of math or maybe just punching it all in. Then number 32 says find the length of each arc. And for number 32, you'll notice they gave us degrees here. We can't use that. And it doesn't matter that it's negative. I just need to figure out that 285 degrees. So what I need to do is my unit analysis telling myself, okay, I need degrees on the top and the bottom, so that will cancel out. And then I need radians to be on the top, so that's what will be left. So here, we're going to get those to cancel out right away. And then we'd want to reduce 285 and 180, and definitely 5 will go into both of those. Even more so, let's see here. Yes, so if we go by 15, that will do it. So this will end up with the 285, up here we'd have 19, and then with the 180 we would have a 12. So this will be 19 pi over 12, and of course the one label we have left there is radians. And we need to take that times the radius, which is 150 feet. So we'll have 150 times 19 pi over 12. Let's see what we get here. 150 times 19 times pi, and divide all of that by 12. 746.1282552. Just said find the length of each arc. Typically that would mean we're going to go to tenths, but in this one, I'm going to go ahead and go tenths anyway. About 746, and this would be feet. And we wouldn't talk about it as a negative 746 feet. So again, remember that the angle measure that we use for this is not going to be negative. 33 a little nicer because they already have that one radians for you, so I think I'm going to leave that one for you to try. Draw an angle in standard position with each given measure, then find values of the cosine and sine of that angle. This is very similar to one that I just did a little bit ago here, where we have to think of 5 pi over 2 as, in fact, a mixed number. So 2 goes into 5 twice, and 1/2 pi. So what does that tell me? Well, what it tells me is, here's my initial side. I have to go all the way around 2 pi with this one. And then I have to go 1/2 pi again. So 1/2 pi actually brings me right up there, which is a 90-degree angle. And if it's an all right, took a second here to think about how I want you to do this one. There are so many different ways to think about the 90 degrees, and I had to go back to what was it that I had taught you about this previously. Because you could, and I will certainly let you guys all punch this in as 90 degrees and just use your calculator to do it. But I do want you to also remember that we do use the coordinates here of the unit circle, thinking that, hey, this is 0, 0, and this would be 0, 1. And then we can remember that to find sine, cosine, and sine, we can do things like y over r, x over r. We could do tangent as well, but they didn't ask for that here. So then you start thinking, well, how do you find r? Well, r is the square root of the x squared and the y squared, so 0 squared plus 1 squared. So r is just going to be 1. So if we need sine and cosine of this, and that's what they want, and it really is the sine and cosine of 90 degrees, but I'm going to put theta this time. What we need to do is remember, okay, sine was y over r. Well, our y value here is 1, and 1 over 1 will give us 1. And we are still looking at basically first quadrant here. Everything is going to be positive. And then the next thing we would do is we would say, okay, well, what do I get for cosine? Well, cosine is x over r. So that's going to be 0 divided by 1, which is just going to be 0. And they did give these to you in the order of cosine and sine, so I want to make that match what you're taking a look at in the back of your book. So again, you double check. We're talking first quadrant, everything is positive, and that's what we would get for that one. And number 55 says, what is the exact value of the cosine of 5 pi over 4 radians? I see the 4 on the bottom and think 45 degrees right away, but of course we need to know, where is this located at? Where will that 5/4 pi be? And that's 1 1/4 pi. So what we're going to have to do is visualize that we've gone 1 pi and then 1/4 more. And that means we are definitely looking at 45 degrees right here for our angle. You think about that unit circle and what's going on there, but we're really forced to think about that 45-degree angle there. So then you sing the song, or you remember 45, 45, 90. These are easy to name, for it's 1, 1, square root of 2 in the triangle game. So this is going to be a -1. This is going to be a -1. And the radius there will be a positive square root of 2. And it said, what is the exact value of the cosine? So cosine means that we're going to want to use adjacent over hypotenuse. Well, adjacent is a -1. And hypotenuse is a square root of 2. We recognize that we can't leave that, so we're going to go ahead and multiply by the square root of 2 on the top and the bottom. So the cosine of theta, in this case 5 pi over 4, is really what we should use there. is going to be a negative square root of 2 over 2. And that's the cosine that we needed, and that is answer G, since this was multiple choice. Now, that is the last one.